Now, one thing about random chance is it doesn't always give you the correct answer. So, even if you have lots of evidence, you can still make the wrong decision. That is, sometimes you may go with the alternative hypothesis when the null hypothesis is really true. Sometimes you go with the null hypothesis when the alternative is true. Sometimes it's just a way that random chance works. Is sometimes you'll end up with the wrong answer. If you think of the court systems we have, innocent people are sometimes wrongly convicted, the guilty sometimes walk free. Likewise, we can make a wrong decision with a statistical hypothesis test. However, the difference here is that we have the tools necessary to quantify how often we make these errors. And that has a lot to do with why we choose 0.05. Anyway, we have two competing hypotheses, the null and the alternative. In a hypothesis test, we make a statement about which one we might be true, but we might choose incorrectly. So there's 4 possible scenarios for an hypothesis test, as we summarize here. So right here in the upper left, that's where the null hypothesis is true, and we don't reject it. So essentially, we think the alternative hypothesis is plausible. That would be a correct outcome. On the other hand, over here in the upper right, this is where the null hypothesis is really true, but we reject it and go with the alternative. This is what's known as a false positive or a type 1 error. A type 2 error is when the alternative is really true, but we fail to reject the null hypothesis. This will often happen if, say, for instance, our sample size is too small and we're not able to reject it. Or, again, could just be the effects of random chance. The bottom right, this is where the alternative is true, and we do reject the null hypothesis in favor of the alternative. So the alternative is true, and we go with the alternative. This would also be a correct outcome. So going back to those 2 errors, a type 1 error occurs when the null hypothesis is true, but random sampling caused our data to appear to support the alternative. So these types of errors, such as when a person is wrongly diagnosed as having a disease, are known as false positives. On the other hand, a type 2 error occurs when the null hypothesis is really false, but random sampling caused our data to not reject it. Again, it could be random chance, or it could just be our sample is just too small. Regardless, either way, we're not able to reject the null hypothesis. So these types of errors, such as when an infected person is given a clean bill of health, are also known as false negatives. So here's sort of showing a difference between false positive and false negative. False positive is when the person is when they're diagnosed as being pregnant when they really aren't. False negative, they're not pregnant when she really is.